Let's get started. But what exactly is a free body diagram? A free body diagram is a simple sketch that shows all the forces acting on an object. Imagine you're isolating an object/system from the rest of the world and identifying every push, pull, or interaction it experiences. This is a normal force. It is a contact force that is always perpendicular to the surface. This is Fg, the gravitational force. It is the force exerted by Earth, not gravity. This is Ft, the tension force. Tension is the force transmitted through rope, string, and more. It is a pulling force. This is Ff, the friction force. This force is generated by two surfaces that contact and slide against each other. Surface texture affects Ff. This is usually a pushing force. Let's break it down. First, you should identify the system you're analyzing. Second, replace that system with a dot. Size doesn't matter. Third, draw arrows to represent the forces acting upon it. Size matters. Fourth, label each force with on-by notations. Let's dive into our first example. A cat sitting motionless on a couch.
Wait, since the cat's motionless, is this a balanced force?
Yes, you're exactly right. Please pause video to attempt the problem. This should be the answer you got. Why is this correct? It is correct because there are hash marks representing its congruency. This diagram represents that this motion is balanced. It also includes correct on-by notations. Let's dive into our next example, where a cat is resting motionless on a slanted rooftop.
Wait, do we need to know that friction is parallel to the surface to attempt the problem?
Yes, you're exactly right. That is vital information needed to solve this problem. Please pause video to attempt the problem. This should be the answer you got. Why is this correct? It is correct on-by notations pointing in the right directions. Fn is perpendicular to the surface. Ff is parallel to the surface. Fg balances Fn and Ff, showing that the cat is motionless. One key concept you need to know is that this free body diagram does not have any hash marks because the separate forces themselves aren't equal, while Fn plus Ff is equal to Fg. Let's dive into our next example. A cat jumping off a chair. Make a free body diagram for a cat while it's in the air. How many forces are acting on this beautiful cat? How many do you think? Please pause video to attempt the problem. This should be the answer you got. Why is this correct? It is correct because there's no normal force on the cat, because the cat doesn't have any contact to anything. This force body diagram represents the cat's motion as non-uniform because the cat is unbalanced, which is true.
Should my free body diagram represent the object's motion?
Yes, if your free body diagram doesn't represent your object's motion, then you're doing something wrong. I would like to end with a quote located in Mr. Fallmer's room. If you can't have fun with physics, you aren't a very fun person. Life without physics is a catastrophe. Thank you for watching.